Hello everyone. So in this video session, we are going to learn more about ion selective electrodes. As the name suggests, ion selective electrodes are those electrodes which are selective to a concentration of particular ions in the solution. So these electrodes actually generate a potential or give a potential depending upon the concentration, or you can say activity of specific ions. One such example of ion selective electrode we have seen in the previous session, which was the glass electrode. Glass electrode gives a potential value which depends upon the concentration of H plus ions when it is connected to a reference electrode which is having a constant potential. So glass electrode is one example of ion selective electrode. So in ion selective electrode, if you see, the main thing is that these solutions of ions are separated by a membrane. So taking example of glass electrode again, in glass electrode there was a glass membrane which was separating two solutions of H plus ion. Solution 1 which was present inside the glass electrode, which was of a constant concentration, and this is the second solution which you can also call as the test solution or an analyte, in which we don't know the concentration of H plus ion. So when this ion selective electrode is in contact with the sample solution or an analyte, this ion selective electrode will produce a potential which will depend on the concentration of this ions which are present in the analyte when it is connected to a reference electrode of constant potential. So this is general principle of ion selective electrodes, that they produce a potential which depends upon the concentration of a particular ion or a specific ion present in the solution. So for better understanding, if you have not seen my previous video on the glass electrode, you can go and see it for reference. Moving ahead, in today's session, we are going to see such different types of ion selective electrode. So there are total 5 types of ion selective electrode depending upon the membranes which we are using. So the first one is glass membrane electrode. The best example of this is the glass electrode. So the first glass ion selective electrode to be developed was sensitive to the H plus ions. So glass electrode gives the potential which depends upon the concentration of H plus ions present in the analyte. Second type is liquid membrane electrode. So in this case, the membrane which is going to be used is a liquid membrane, and this consists of a liquid ion exchange membranes in the electrode. Third is solid state membrane electrode, means the membrane would be in a solid state, means it can be a crystal of inorganic compounds doped with some rare earth metals, or it can also consist of a sparingly soluble salt. Next is gas sensing electrode. So in this electrode, we can actually measure, or these electrodes give the potential depending upon the concentration of the gas present in the solution. But first, that gas is converted into ions, and then this electrode will give a potential depending upon the concentration of those ions which we have got from the gas molecules. Last type is enzyme based electrode, also called as biochemical electrodes. So in this type, we use some enzymes in the membrane of the electrode. The role of these enzymes is to convert some compounds which are present in the solution, sample solution, into ions, and then that electrode produces a potential depending upon the concentration of those ions present in the solution. So we are going to see this with the help of example. For gas membrane electrode, we have already seen glass electrode in the previous session. And in this session, we are going to see solid state membrane electrode, gas sensing electrode, and enzyme based membrane electrode, that how exactly they operate. Also, these are ion selective electrodes. These are the type of indicator electrodes whose potential value is going to vary depending upon the concentration of the specific ions present in the solution. They are going to give the potential when they are connected to a reference electrode of constant potential. So we are going to form a cell in this. So here in this session, we are only going to see the individual ion selective electrodes. So this is the first one, which is the solid state membrane electrode. So in solid state membrane electrode, the membrane, in the membrane of an electrode, there is a crystal of inorganic compounds doped with rare earth metals, or it can also contain sparingly soluble salt. So this is the example of it. You can see here we have an internal electrode which is connected to the potentiometer to measure the potential. So this is silver silver chloride electrode, and there is an internal filling solution. Also here you can see in the membrane there is an inorganic crystal. So if it is a fluoride ion determination, then the crystal which we are going to use here, it would be of lanthanum difluoride, which is doped with europium fluoride. So you can see this is the crystal structure of lanthanum fluoride or lanthanum difluoride doped with europium fluoride. So here the ions you can see are europium ions and fluoride ions which can migrate easily. There are some vacancies in its lattice. So the crystal is sealed at the bottom of polymeric container containing internal reference solution, which is NaF plus NaCl, or it can be Kf plus KCl, and it consists of a reference electrode as well. So it is going to have an internal reference solution as well as the reference electrode. So this will be connected to the reference electrode. So this type of crystal is used for determination of fluoride ion. If you have to determine the concentration of fluoride ion, then the crystal uses lanthanum trifluoride doped with europium fluoride. Sorry, it is lanthanum trifluoride doped with europium fluoride. Next is chloride ion determination. Again, it comes under the solid state membrane electrode. So in this case, again, here in the membrane, there would be a solid crystal, but since it is chloride ion determination, so in this case, it would be pellet of silver sulfide and AgCl, silver chloride is used. So here again, you can see this is the internal electrode. This is a plate. AgCl electrode can be used. There is an internal reference solution which we call as an electrolyte, and the electrode is made up of Teflon body. So ethylene tetrafluoride is Teflon. So this is the pellet of the electrode which is held at the bottom position with epoxy resin. So what pellet or what solid crystal we are going to use, it depends upon depends upon on which concentration we need to measure. If it is fluoride ion concentration we need to measure, then we use lanthanum trifluoride doped with europium fluoride. If we have to find the concentration of chloride ions, then it would be silver sulfide with silver chloride. So when this electrode is dipped in a sample solution, it will develop a potential depending upon the concentration of chloride ions which are present in the sample solution. So that's all for this video. In next video, we are going to see enzyme based membrane electrode and gas sensing electrode. If you have any doubts, you can simply put it in the comment box, and if you like my video, kindly like, share and subscribe. Thank you.